Welcome to my YouTube channel, Kanglaipak Study Support. Hi, my dear students. Today, we will discuss the following topics. The topics are expression of equilibrium constant in terms of molar concentration and partial pressure, relationship between Kp and Kc, and units of equilibrium constant. So, without wasting any time, let's begin the class. To express equilibrium constant in terms of molar concentrations, let us consider a general reversible reaction taking place in liquid phase. Okay, that general reversible reaction is X mole of reactant A plus Y moles of reactant B, reversible symbol L moles of product C plus M moles of product D. Okay, this is the general reversible reaction, and this reaction taking place in liquid phase means all the reactants and products of these reactions are in the liquid phase. Then the equilibrium constant for the above general reversible reaction may be expressed as Kc equal to concentration of C power L, concentration of D power M divided by concentration of A power X, concentration of B power Y. In this expression, the symbol third bracket A, third bracket B, third bracket C, and third bracket D represents the molar concentrations of A, B, C, and D. Okay. Then the symbol X, Y, L, and M represents the number of moles of A, B, C, and D respectively. Now I will explain you in Manipuri also. Equilibrium constancy molar concentration के term de express तौनबगीदमक्ता general reversible reaction liquid phase ता थोकपा general reversible reaction ama खनरसी हारिबा general reversible reaction liquid phase ता थोकपा दुदी X mole of A plus Y moles of B, reversible symbol L moles of C plus M moles of D. Okay, हारिबा general reversible reaction si liquid phase ta thokpa haibadi magi reactants amasung production si liquid phase ngakta oi haibani asigumba liquid phase ta thokpa general reversible reaction asige equilibrium constant express tawge hai taragadi liquid phase ta thokpani na ma molar concentration gi term de express tawgani aduna molar concentration gi term de express tawraba equilibrium constant na dudi Karino haiba matamda Kc haiba symbol sina represent tawgani aduna Kc gi expression si asumna iba yai Kc equal to concentration molar concentration harini third bracket C molar concentration of C power L into molar concentration of D power M divided by molar concentration of A power X into molar concentration of B power Y. Yare ko aduna masigi expression si sizinariba third bracket A, third bracket B, third bracket C, third bracket D hairiba si symbol sing asina represent tawriba si molar concentrations of A, B, C, and D haidana mathau manau naina represent tawribani aduga symbol X, Y, L, and M haina iriba sina represent tawribasina reagent oiriba A, B amasung product oiriba C amasung D gi number of moles pu mathang manau naina represent tawbani aduna reversible oiba reaction ama liquid phase ta thokpa taragadi hairiba reversible reaction liquid phase ta thokpa reversible reaction adugi equilibrium constancy molar concentration ge terms da express tawgani magi symbol buna Kc oina sizinagani. In the previous class, that means at the part 2 of this chapter, we have already discussed the derivation of the mathematical expression of equilibrium constant in terms of molar concentration. That means the mathematical derivation for the Kc. Okay, This is the expression of equilibrium constant in terms of partial pressure, okay? So to express the equilibrium constant of a reversible reaction in terms of partial pressure, let us consider a reversible general reaction which is taking place in gaseous phase. That general reversible reaction is X mole of A plus Y moles of B reversible symbol L moles of C plus M moles of D, okay? That means this general reversible reaction is taking place in gaseous phase, means all the reactants and products which are involving in this reaction are in the gaseous phase. Okay, clear? Now, for such a reversible reaction which is taking place in gaseous phase, if we want to express the equilibrium constant, we will express that equilibrium constant in terms of partial pressure, which is symbolized by Kp. So the equilibrium constant in terms of partial pressure Kp is expressed by the mathematical expression Kp equal to Pc power L into Pd power M divided by Pa power X into Pb power Y. In this mathematical expression, the symbol Pa, Pb, Pc, and Pd represents the partial pressure of A, B, C, and D respectively. Okay, clear? The symbol X, Y, L, and M represent the number of moles of A, B, C, and D respectively. Okay, now let me explain you in Manipuri for better understanding. Equilibrium constancy partial pressure ge term the express tauge hai taragadi khanagadoriba reaction adu gaseous phase ta thokpa reversible reaction oiba tai aduna ai koi gaseous phase ta thokpa general reversible reaction ama khanarasi reaction adu di X mole of A plus Y moles of B reversible symbol L moles of C plus M moles of D. Okay, masigi general reversible reaction asi gaseous phase ta tho A haina khanarasi gaseous phase haibadi aina haigre masida involved tawriba saruk yariba reactant amasung product sing se loina gaseous phase oi haibani adu ai targadi asigumba gaseous phase ta thokpa reversible reaction amagi equilibrium constancy express tawge hai targadi partial pressure ge term de express tawgani gaseous phase ta thokpani na asigumba gaseous phase ta thokpa reversible reaction asigi equilibrium constant de aikoi molar concentration ge term de express tawroi partial pressure ge term de express tawrni aduna equilibrium constant expressed in term of partial pressure sibu symbol oina Kp haina represent tawi aduna Kp is equal to Pc power L into Pd power M divided by Pa power X into Pb power Y haidana mathematical expression ama lere masigi mathematical expression asita sizinariba symbol Pa Pb Pc and Pd haribasi Ab amasung C amasung D hariba sing asigi partial pressure singni aduga symbol X, Y, L, and M haribasina A, B, C amasung D sigi number of moles masingduni. Aduna aikoi hujik clearly khange madudi karigumba reversible reaction ama gaseous phase ta thokpa taragadi reversible reaction adugi equilibrium constancy partial pressure ge term de express tawgani equilibrium constancy partial pressure gi term de express tawragadi madugi symbol bu Kp na represent tawi aduga atopa amada karigumba reversible reaction ama liquid phase ta thokpa taragadi hariba reversible reaction adugi equilibrium constancy in terms of molar concentration de express tawgani equilibrium constant in terms of molar concentration sibuna Kc da represent tawre yantare ko. Now, let us see what is the relationship between Kp and Kc. I have already mentioned you that Kp represents the equilibrium constant expressed in terms of partial pressure and Kc represents the equilibrium constant expressed in terms of molar concentration for a reversible reaction. Okay. The relationship between is Kp equal to Kc whole into RT power del N. Okay. In this expression, the symbol Kp represents the equilibrium constant expressed in terms of partial pressure and Kc represents the equilibrium constant expressed in terms of molar concentration. These are already mentioned you. The symbol capital R is the universal gas constant. It is a specific constant. Okay. If the partial pressures of the reactants A, B and products C and D are taken in atmosphere. Atmosphere is a unit of pressure. Okay. then the value of R to be used in the above expression is 0.08 to 1 atmosphere per degree per mole. But if the partial pressures of reactants A, B and products C and D are taken in kilopascal, symbol of kilopascal is kPa and it is also a unit of pressure. Okay, then use the value of R as 8.314 joule per Kelvin per mole in the above expression. Okay, capital T in the above expression represents the temperature measured in Kelvin scale, and del N represents the change in number of mole. Change in number of mole is equal to number of moles of product minus number of moles of reactants. That means change in number of moles is obtained by subtracting total number of moles of reactants from total number of moles of product. Okay, clear? So, by applying at the above general reversible reaction, total number of moles of product is L plus M minus total number of moles of reactants is X plus Y. Okay, clear? Before continuing to the next class, let me remind you one thing, that if you are new to my YouTube channel Kanglipag Study Support, subscribe my channel so that you can get the latest notification and select all by clicking to the bell icon. If you clearly understand my teaching, press like button and share to your near and dear one. If you have any doubt, please write a comment. Now let's come to the topic units of equilibrium constant Kc. In this section, let us see what are the units of equilibrium constant. Okay, the units of equilibrium constant vary from reaction to reaction. So to study the variation of units of equilibrium constant from reaction to reaction, let us discuss point by point. Okay, the first point is equilibrium constant Kc has no unit when there is no change in number of moles of reactants and products in a reaction. That means in a reaction, if the number of moles of reactants and product are same, then there is no unit of equilibrium constant. Clear? So for better understanding, let us discuss by taking example. So to discuss this, let us consider a reversible reaction in which the change in number of moles of reactants and products is 0. Okay, that reaction is 1 mole of nitrogen molecule gas plus 1 mole of oxygen molecule gas, reversible symbol, 2 moles of NO gas. Okay, in this reaction, total number of moles of reactants is 2 because 1 mole of nitrogen combines with 1 mole of oxygen molecule. So total number of mole of reactant is 2, and total number of moles of product is also 2 because by combining the reactants, the product given is 2 moles of NO. Okay, clear? So in this reaction, there is no change in number of moles of reactants and product. That means total number of moles of reactants and product are same. In such reaction, the unit of equilibrium constant can be calculated by using the expression Kc is equal to concentration of NO squared divided by concentration of N2 into concentration of O2. We know that molar concentration is mole per liter. Okay, so concentration of NO power 2 means mole per liter squared divided by concentration of N2 means mole per liter into concentration of O2 is also mole per liter. By simplifying, we get 0. Hence, equilibrium constant Kc has no unit when there is no change in mole number of reactants and products in a reaction. Clear? Let me explain you in Manipuri also for better understanding. ꯑꯩꯈꯣꯏꯅ ꯍꯧꯖꯤꯛ ꯅꯩꯅꯒꯗꯧꯔꯤꯕꯁꯤ equilibrium constant gi unit si karino haibani. Aduna equilibrium constant gi unit si akaknaba leite masi reaction to reaction khenai haibani. Aduna masi reaction to reaction equilibrium constant gi unit si khenai haibsi khangnaba aikoi point by point oina point amamtang khan lokhalaga nainase. Ahanbada equilibrium constant Kc haibasi magi unit amata leite magi unit si 0 ni haibani. Karigumba थोइबा रिवर्सिबल रिएक्शन अदुदा टोटल नंबर ऑफ मोल्स ऑफ रिएक्टेंट अमसुंग टोटल नंबर ऑफ मोल्स ऑफ प्रोडक्ट चप माना तारगदि हाइबदि रिवर्सिबल रिएक्शन अमदा रिएक्टेंट की अपुनबा मोल मसिंगा प्रोडक्ट की मोल मसिंगा मानारबा चेंज ऑफ नंबर ऑफ मोल से जीरो ओरबा अदु तारगदि इक्विलिब्रियम कांस्टेंट की यूनिट अमता लेते यूनिट इक्विलिब्रियम कांस्टेंट की यूनिट से जीरो नि हाइबनि खंगना बा एग्जांपल अमा लौरगा नाइनसी अखोय रिएक्टेंट की मोल मसिंगा प्रोडक्ट की मोल मसिंगा मानाबा हाइबदि चेंज इन नंबर ऑफ मोल से जीरो ओइबा अदुगुंबा रिवर्सिबल रिएक्शन अमा लौरसी रिएक्शन अदुदि 1 मोल ऑफ नाइट्रोजन मॉलिक्यूल गैस का 1 मोल ऑफ ऑक्सीजन मॉलिक्यूल गैस का पुंजनरगा 2 मोल्स ऑफ NO गैस पुथोकपा अदुगुंबा रिएक्शन अमा खनरसी हारिबा रिएक्शन असिदा रिएक्टेंट की टोटल मोल मसिंग जे 2 नि करिगेनो हाबे मतमदा नाइट्रोजन की मोल मसिंग सु 1 नि अदुगा ऑक्सीजन की मोल मसिंग सु 1 नि मोल मसिंग अनि नाइट्रोजन की मोल मसिंग 1 का ऑक्सीजन की मोल मसिंग 1 गानी से पुंजनरगदि 2 तारे रिएक्टेंट की टोटल मोल मसिंग से अदुगा मबानी से पुंजलगा पिथोराइबा प्रोडक्ट NO से मोल मसिंग जु 2 नि अदुना रिएक्टेंट की टोटल मोल मसिंग जु 2 तारे प्रोडक्ट की मोल मसिंग जु 2 तारे अदुना रिएक्टेंट की मोल मसिंग प्रोडक्ट की मोल मसिंग हारिबा एग्जांपल असिदा मानरे हाइबदि चेंज इन नंबर ऑफ मोल से जीरो तारे हाइबनि असिगुंबा चेंज इन नंबर ऑफ मोल जीरो ताबा रिएक्टेंट की मोल मसिंग प्रोडक्ट की मोल मसिंग मानबसे असिगुंबा रिवर्सिबल रिएक्शन असिगी इक्विलिब्रियम कांस्टेंसी जीरो ओइ हाइबनि मासी खंगनाबा अखोय इक्विलिब्रियम कांस्टेंसी कैलकुलेशन तौरगा यंगसी अदुगी इक्विलिब्रियम कांस्टेंट की फॉर्मूला की मतुंगिना Kc इज इक्वल टू molar concentration of NO power 2 divided by molar concentration of N2 into molar concentration of O2 हाइजे लेरा माथा की जनरल एक्सप्रेशन अखोगी molar concentration Kc गी जनरल एक्सप्रेशन दो मधु अप्लाई तौरगनी होलेइसे अदु अइतारगदि मसी के यागा माना हाबे मतमदा molar concentration हाइजदि मागी यूनिटी मोल पर लीटर नि अदुना NO गी पावर 2 हाइबनि ना NO से molar concentration of NO पावर 2 हाइबनि ना concentration molar concentration की यूनिटी मोल पर लीटर पावर 2 लेरे मगादसु molar concentration of nitrogen into molar concentration of oxygen हाइबनि ना molar concentration of nitrogen दी मोल पर लीटर अदुगा oxygen की molar concentration सु मोल पर लीटर लेरे अनि से पुंजनरगा सिंप्लीफाई तौना तारगदि मोल पर लीटर पावर 2 मोल पर लीटर पावर 2 लेरे अदु इतादि मानरमिना कक्थनरगदि जीरो तारे अदुना Kc गी वैल्यू से जीरो ताबनि ना Kc गी हारिबा इक्विलिब्रियम कांस्टेंट एक्सप्रेस इन मोलर कंसेंट्रेशन दा एक्सप्रेस तरवे इक्विलिब्रियम कांस्टेंट से मसीगे यूनिट सी लेते जीरो ओइ करिगुंबा रिएक्टेंट की मोल मसिंगा प्रोडक्ट की मोल मसिंगा मानब रिएक्शन रिवर्सिबल रिएक्शन अमा ओइ तारगदि हाइबनि जानतारे को next point is equilibrium constant has some units when number of moles of reactant and products is different in a reaction. Okay, for better understanding, let us consider by taking an example. So let us take a reversible reaction in which number of moles of reactant and product are different. The reaction is 1 mole of nitrogen molecule combines with 3 moles of hydrogen molecules and giving the product 2 moles of NH3 ammonia gas. Okay, in this reaction total number of moles of reactant is 4 because 1 mole of nitrogen molecule combines with 3 moles of hydrogen gas. So total number of mole of reactant is 4 here and the total number of moles of product is 2 because by combining the reactants the given product is 2 moles of ammonia. Clear? Understand? So in such cases means in such reactions reversible reactions in which the total number of moles of reactants and product are different. For such reactions the unit of equilibrium constant has some units. So let us find out what is the unit of that equilibrium constant in this case. So by using the general expression of Kc we have discussed already. Now we get Kc is equal to molar concentration of ammonia power 2 divided by molar concentration of nitrogen into molar concentration of hydrogen power 3. Okay, so we have already known that the unit of molar concentration is mole per liter. So mole per liter power 2 divided by mole per liter into mole per liter power 3. Okay, by simplifying we get mole per liter square divided by mole per liter 4. So after cancelling we get mole per liter power minus 2. By simplifying, this again can be written into liter square per mole inverse 2. Okay. So, in this case, Kc has some unit. Okay. What is that unit? That unit is liter square per mole inverse 2. Okay. So, hence, equilibrium constant Kc has some unit when number of mole of reactant and product is different in a reaction. Clear? As a result, usually the unit of equilibrium constant is not mentioned until and unless it is calculated. Clear? We cannot say the unit of equilibrium constant for a given reversible reaction until and unless the unit of that equilibrium constant is calculated. Let me explain you in Manipuri also for better understanding. Mathangi point asina equilibrium constant si magi unit si karigumba khara sam unit khara di lai habini karigumba khana riba reversible reaction aduda reactant gi mole masinga product ki mole masinga ji khana raga di habini aduna aikoi masi hena khangna na ba example or ga yengse aduna aikoi na khana ga daru ba example ase reactant ki mole masinga product ki mole masinga khana ba adugumba reversible reaction ama lawrase reaction adudi 1 mole of nitrogen gas ka 3 moles of hydrogen gas ka punjal laga reversible small layer pithore ac 2 moles of ammonia gas ni high reaction si reversible reaction ni high reaction si the total number of mole of reactant si 4 ni maram di nitrogen ki mole masing 1 ga hydrogen ki mole masing 3 ga punjal le adu ga pithore liba total number of mole of production 2 ni karigina ba matam da mabani reactant ani se punjal pithore iba mole masing je ammonia gi total mole si 2 ni yare ko aduna reactant ki mole masing ga product ki mole masing ga jikhanai haiba asigumba reactant ki mole masing ga product ki mole masing ga khana ba asigumba reaction asida equilibrium constant ge unit se kari no ama natraga madi lai habni kari unit lai ga dagi habdu di habang amde calculation tawdge khoi khang bangam ko aduna calculation tawra yengsi kc ge general expression aikoina hana tamgi to sizinaraga aikoi hujik iba ya dipsi kc is equal to concentration of ammonia power 2 divided by concentration of molar concentration habni ko concentration idea molar concentration of nitrogen into molar concentration of hydrogen power 3 laire masi simplify tok targadi molar concentration gi unity mole per liter ni haire aduna mole per liter square divided by mole per liter into mole per liter power cube laire simplification tawraga mole per liter square by mole per liter power 4 laire adi cancellation tok targadi mole per liter power 2 power minus 2 laire masi amok reproduce tawrakanta liter square per mole inverse 2 power inverse 2 laire aduna equilibrium constant gi unit sik ama natraga ma kari no khara di thole hariba condition de thole isi liter square per mole inverse 2 power inverse 2 haibasini natra aduna equilibrium constant gi unit se laire haibani kari gi lairi bana reactant gi mole masinga product ki mole masinga khena reversible reaction oibagi aduna aikhoina haibe yari se supna hairabda haidi samna hairabda equilibrium constant gi unit se reactant ki mole masinga product ki mole masinga khena taragade magi unit se karigumba khara dil lai hariba unit se kaya ogadage haibu de khona calculation tawdga haiba ngamde adubo equilibrium constant gi unit se laite 0 oi karigumba khana reversible reaction aduge number of moles of reactant ga number of moles of product ka si chap mana taragadi haibani yare ko